Hello, dear students, and today we will have our one new lesson about Introduction to Energy Engineering. My name is Tatiana Vladimirovna. Let's start. The course outline. This is an introductory course teaching you some basic stuff about where your energy comes from, how electricity is produced, renewable and non-renewable energy, climate change and global warming, how your energy future is looking. First of all, you should know that energy engineering is a rather recent engineering discipline that is related to energy, its management along with its production. Energy engineering combines knowledge from physics, math, chemistry, economic, and environmental engineering. Energy engineering sub-disciplines. Energy engineering has been divided into a number of sub-disciplines which are also follows. First of all, this is energy efficiency, energy services, facility management, plant engineering, environmental compliance, and alternative energy, of course. Energy engineering, also known as energy systems engineering, is a new and broad field of engineering which deals with renewable management, energy audit, and environmental compliance. Energy engineers may specialize in electrical systems like heating, ventilation, air conditioning systems, green buildings, lighting, air quality, or energy procurement. They use the principles of engineering and economics as well as soft skills needed to solve practical problems in the energy industry ranging from producing to processing, storage, distribution, and consumption of energy. Energy engineers design and develop renewable energy systems such as wind or solar photovoltaic power plants. Energy engineers are involved in projects to increase energy efficiency and decrease energy consumption, thus reducing overall costs. So they do so by designing, building, auditing, and remodeling existing systems of energy procurement methods. Energy engineering is a very flexible discipline. Energy engineers not only work with industries focusing on renewable or sustainable sources of energy such as hydro, biofuels, wind and solar power, but they also employed in other industries such as in oil and gas extraction industry. The main job of energy engineers is to find the most efficient and sustainable ways for the operation of buildings and manufacturing processes. Energy engineers monitor and analyze this use of energy in those processes and propose ways to tweak and optimize the systems or replace them with more efficient ones. Energy consumption minimization is a key purpose of this discipline. At this page, you can see how Earth's energy budget and global energy resources work. Earth's energy budget is really, I suppose, interesting and major part of our lesson and of our whole knowledge and experience. Uh, Also, I have a question for you. Do you know where the Earth's natural resources come from? Of course, the answers are the following: fossil fuels, uranium, solar energy, wind energy, tidal energy, and so on. Most are driven ultimately by solar radiation. On Earth, there is a complex interaction between subsystems involving oceans, cloud, land, volcanoes, plants, animals, and so on, so-called natural cycles. Although man has invented somewhat to dispute this, scientists define specific cycles to model flows between subsystems, for example, carbon cycle or hydrological or water cycle. Exactly, this is the picture, and this is the example of symbolic carbon cycle diagram. It's really interesting and it's really important to know how to symbolic carbon cycle diagrams works. I hope that after today's lecture you will know a little bit more about this. For example, here we have oceans, also oceanic carbon. Also here from the left side we have fossil fuels and decomposition. Also here we have a biospheric carbon like life forms. In our atmospheric carbon we have different position like from the fossil fuels we have a composition. Here we have our photosynthesis. Here we have respiration and metabolism. And this is our diffusion. And of course, this is our sun. This is the example of our hydrological cycle. It's also very important. This is our precipitation consideration. This is our solar energy. Also here we have our water vapor transport. This is our evaporation. This is our evaporation, ocean, evaporation, and this is our runoff. From the right part, from the right picture, you can see how cold high pressure works with warm or low pressure. And our Earth's energy budget exactly works with the Sun, is responsible for most of Earth's energy resources. The surface of Sun has a temperature about 5,800. At that temperature, most of energy the Sun radiates is visible and near infrared light. The energy is in energy balance. That's why it maintains a roughly constant temperature of about 288. And the sun shortwave radiation impacting on Earth is balanced by the thermal or long-wave radiation emitted by Earth. Guys, after this task, after this lecture, you will have some tasks and they are optional to do after you will learn this unit. See you soon. I wish you good luck.